Good evening, everyone. My name is John O'Connell. You're all very welcome to the Engineers Ireland West Region webinar tonight. It is titled Building Tomorrow's Homes Today. As the building regulations push Ireland towards greener buildings, our emphasis needs to change, or needs to focus on the construction stage and our material selection. The west of Ireland in particular has been slow to implement new building technologies, as block and mortar has dominated construction sites until recently. This evening we'll have three presentations on different systems, starting with Gareth McMeekin from BuildWright. He'll be presenting on concrete modular homes. Then we'll have John Moylan from SIP Energy. He'll be presenting on structurally insulated panels, followed by Gerard Clarke from FastHouse presenting on timber frame construction. So each company will be presenting for 15 minutes. This will be followed by a Q&A session at the end. You'll be able to ask your questions with the Q&A function within the Zoom app. So I'm going to hand you over to Gareth to make a start on tonight's presentations.
Sorry, we're unmuted now. Thank you very much, John. Just let me organize my screen here. Okay, hopefully you can see my slides. Thank you very much for this invitation to the West region. On all my travels across the country, it's probably the part that I'm least in. It would have been nice to take a trip to you tonight, but that's just not possible. I've been asked to talk a little bit about our build system, and so I want to take you through a little bit of our journey to the product and a little bit of technical detail about the product. BuildWright is the name of the company, and we settled just about a year ago on the tagline just below, which is to make building simple through innovation and excellence. And we do that through a concrete modular building system. There are lots of different ways to build, and no one system is right all the time, but we feel that this in particular has something to offer. My own background is that I trained as a civil engineer, a chartered engineer and a fellow of the Institute of Engineers in Ireland, and currently I go under the title of Strategy and Innovation Manager at Wright Concrete Innovations. I've been around the industry for almost 20 years and been part of both the Concrete Society and the Concrete Federation over those times, feeding back into some of the work, particularly in the field of concrete. So just to give you a little bit of information about the background of modular, how we came to modular, and why we believe that modular and our system have something to offer the industry with some of the current challenges. Lots of modular or off-site construction companies have different journeys. Journeys rooted in a family business that began over 60 years ago, and so it's not been a company specifically built for modular construction, but one that has progressed through supplying quarry industry in the early days, ready mix, precast concrete. And we developed up until 2008, whenever the crash happened, and probably at that time we had ideas of where we would go. We had to kind of reform, first of all, buckle down, sort out financial stability, develop sales and marketing across to the UK and other places, and then redevelop the company culture in those years after 2008. And after we'd kind of settled a lot of those things down, it came back to looking at the whole idea of developing our product and developing the technology within the business. The background to redeveloping that technology is that the company believed quite strongly in two things. It believed that off-site construction had an awful lot to offer. We had our roots in that in both agriculture and residential house construction with precast elements. We believe firmly that making things off-site rather than on-site has something to offer in terms of productivity and comfort, and as well as that, we believe in the product that we sell. We believe that concrete is something that has real value to offer the industry. just by means of definitions, and hopefully this agrees with the other speakers who are here tonight, but we talk in modular, we talk about two different things. We talk about panelized modular and volumetric modular construction, and those terms themselves probably explain with the pictures that are on your screen. And we had done some work on the panelized kind of system, but we felt that we needed to look into what could be done to make a concrete offering in the volumetric space, that is in three-dimensional offsite, which allows more finishing to be completed in the factory than in simply panelized construction. And we believe in concrete, and this slide is taken from the concrete industries site. We believe in concrete because it's built to last. It offers a comfort in terms of thermal mass and other things that are incorporated in it. It's an exceptionally resilient product, a fire-safe product. It can be engineered to the same levels of energy efficiency that any other system can, and in its own way, it offers sustainability. And so that's kind of where we came from, just to look at what drives modular construction. And I hope you agree with me that certainly the 5 things on the screen are 5 of the biggest challenges that we face in the industry. Skill shortages is a major issue, shortages of trades. We just had a little prelim conversation about that before you joined us. Increase in standard of build and standard of finishes, increased compliance with standards. The health and safety management is consistently up on a level and brings its challenges. The management of waste and material efficiency and the management of cost are also issues. And finally, financial certainty is one of our big challenges. And we feel, and many in the industry, you'll see the note at the bottom of the McKinsey report in the UK, those kinds of things push very much towards these challenges being partly met by the interest of modular offsite construction. The Engineers Journal published in July of last year this figure that modular construction in Europe and the US could deliver annual savings of up to 22 billion. And so modular construction is not just of interest to engineering professionals, but it's of interest to politics as well, and to the larger efficiency of the industry. And so these are some of the reasons that we look towards modular construction. One of our challenges in the concrete industry is that the idea of telling someone that you're proposing to try and make concrete boxes doesn't particularly fit with the architecture and style of what they expect in a house. And so we've had to spend some time developing the idea that even though our core piece is a concrete box, it contributes to very acceptable, even desirable designs. So as we came out of that whole period of innovation, really we've been on a journey over the last 5 to 7 years, a little bit of funding from Enterprise Ireland and some international contacts that worked in the direction of, in 2018, building our first prototype house. And since then, we've stuck mostly at one-off installations, one-off houses. We felt that the product needed developed first of all over those kind of projects. And so to date, we've about 20 projects completed. And I know that some of the other speakers tonight will have much more, a much wider variety of projects than that, but that's kind of the journey of where we've come to. A little bit about the product. Our idea was to take that core wall element and work on what was in that wall to put into it advanced concrete mixes. The types of concrete we use aren't really used for anything else in Ireland. They're used for very specialized purposes across Europe. Put in specialized design that takes consideration of all that we can do to maximize structural efficiency. Put into that wall the insulation, put in the services, and to produce out of that system a high-performing thermal system, a volumetric structure that enables us to do the finishing in the factory, reduced construction weights, and also improved resource efficiency. Those boxes, the idea then is that all of that goes into a wall which is concrete. Others do that in other types of material. The idea is that we make a panelized production, and then in the assembly, those panels are assembled into a volumetric unit. The standard volumetric unit is approximately 10 meters by 4 meters. We can accommodate a certain amount of voids in panels, and we can either produce flat boxes for stacking, or we can put a pitched roof on the boxes. And the transport constraints rather than the structural ones remain key to the parameters. The wall makeup is essentially an internal gypsum skim finish with a concrete structural core. That structural core is then externally insulated, and the core and the insulation vary at points to give maximum structural efficiency. And then an external render system is applied to the kind of standard setup. To that we can vary the external finishes, but as a kind of standard we look at just a render system. Just in terms of understanding how we finish, the picture on the right of your screen is of a module in the yard ready to go to site. And on the left are the pictures of it arriving on site. Once it got to site, the centre corridor had to be completed, which took around about 2 weeks. But it gives you an idea of the speed, the readiness that's there for going to site in terms of pretty much a full fit out inside with just joints to be accommodated. Doing things in-house and the level of material innovation that we've had to do, we've installed probably the most advanced test system for the type of concrete that we have in-house, so that our test results are close to our factory floor and we understand what's going on. And I suppose I, as a civil engineer, began the whole process thinking once we had solved the structural problem, everything else would fall into place. I've understood much more fully that there are lots of other things that have equally as much bearing as the structure, and the design has had to take account of fire and sound and thermal values, moisture ingress and condensation risk, air tightness, all those things that possibly you already know about. But the design of a system like this is much more than just structural design. So just to summarize the technical content, we believe in modular because it offers a condensed and reliable build program. It offers cost certainty, improved quality control, it's relocatable and reusable, it's scalable space, it's cost-efficient construction, and it's hassle-free in terms of the skills required on site. But it's also a concrete building, robust and built to last, fire-safe and thermally efficient, comfortable, resilient and sustainable. Just looking quickly at this initial project which we took on, in April or May of 2018, we embarked on constructing a 3-bedroom house on a rural site. It was made up of 4 modules plus some panelized construction that you can see in the diagram. And in terms of the speed of construction, groundworks for that began in February 2018. Prior to that, in March, November through to March, the work had been undertaken in the factory to get things ready for that house. The interior fit out had happened in those modules, and they were pretty much ready when they went to site. Installation took place on the 26th of March, and the modules, I think, were all in place on the first day. By the second week, the roof had been completed on that building, and the structure was watertight. Because there was quite a bit of panelized construction in the centre of the house, and that took a few weeks to finish. But by week 9 of the construction, that house was ready for occupancy, and it really condensed the program. You know as well as I do how long it takes to produce things like that. So just, I suppose, by way of summary, we were asked to address particularly 3 issues: sustainability, energy efficiency, and cost effectiveness. And just to say a word or two about each of those things. In terms of sustainability, obviously the carbon issue is one that weighs heavily on the agenda whenever cement is involved. And yet, we feel quite strongly that the durability of concrete offers something that offsets the initial carbon, and it's actually something that we have embarked on a project for the next 18 months to look at how this carbon issue compares across the various forms of sustainable construction. But we do believe the extended lifespan available, our design times are 100 years plus, that has to offer some value. And it also, in terms of sustainability, the factory environment offers something that can't quite be achieved in the same way on site, and we have to look at sustainability instead in terms of safety that's sustainable, quality that's sustainable, and even if training of young people to come into the trades, all those things look an awful lot more attractive in a factory environment or in a majority factory environment. And we also need to think in terms of sustainability about our housing stock in the country and how often we need to be rebuilding as time goes forward. In terms of energy efficiency, the house is one of the only volumetric modular systems that offers thermal mass, which is something that's of value in terms of energy efficiency, and it's an exceptionally efficient process in the factory in terms of the build process. Cost effectiveness, this is of great interest to us, and understanding cost comparisons is like trying to hit a moving target most of the time. But I would ask the question, what can you save by saving time on site? And in our experience, even with the site elements of modular builds, the time on site is far and away the most costly time. And getting things right in the factory and getting them out on site has to provide savings. And we have found that our build system, as far as our customers are concerned, has been otherwise comparable. We're definitely not a much cheaper system than the alternative construction methodologies, but we've been found to be comparable in everything that we've done. It doesn't multiply cost, and if it's properly managed, I think there's huge savings in terms of those site costs. So to close, you can maybe make your own judgment whether we've done anything to advance making building simple through innovation and excellence, but hopefully the few minutes that we've had have been useful in terms of giving you an understanding of what we do. John, I'll hand back over to you.
So we'll have John Moylan talking next.
Yeah, okay.
You right there, John?
Yeah, thank you. Yeah, I'm ready. I'm just sticking to my screen. Thanks, Gareth, for that. Very interesting. Right, we'll go straight into it. And I'll just, so I don't run out of, I'll just set my own timer here just so I don't forget where I am. Okay, basically, thanks for the opportunity to explain this. Anyway, in common with the other panelists this evening, we're always keen to get out there in front of people, not only decision makers, but people behind the decision makers, and influencers, engineers are certainly part of that process, and anything that shares knowledge is always good for us. So, I mean, short background on ourselves. I mean, this is actually a 5th generation family business based in Athenry, County Galway, and we can trace the family business back to about 200 years, originally to town farriers and blacksmiths, and working their way up to different technologies and industries over the years, culminating in the operation that we have today in Athenry, with about 40 years discrete experience in composite panel manufacture alone, on top of other things. we operate from manufacturing environment specifically for panels in Athenry, using CNC machinery on the whole, and high quality timber, OSB, adhesive and insulation. To that end, we have to have the supporting crew like all the other companies. We have in total across the site about 100 people. So we have everything from management, system design, manufacturing, quality. Probably uniquely as well, we have our own transport in-house because it's a tradition that we have, and our site crews on site are directly employed by the factory, and we even own the crane. It gives us an element of control, but also it keeps a handle on quality for us. I suppose the first question to get out of the way is, what is a SIP panel? So SIP panel, SIP, is structural insulated panel. It's generally, there are only 4 components in it: timber, OSB, structural adhesive and insulation. It's a manufactured and layered up project to deliver walls and roof panels. So essentially you end up with a wall that has a solid timber face on the outside and the inside, and internally, okay. Well, anyway, getting into the nitty-gritty of it, the panel is made of 4 components. You can see there on the screen on the left-hand side. OSB laminated onto insulation, laminated onto OSB, some timber in it depending on the purpose of the product, point loads and so forth. Uniquely in the SIP panel industry, in the timber SIP panel industry, we can include services for the likes of cabling and so forth. And on the right-hand side there, you should be able to see a typical section of what a building is. So we go on to any number of foundation types that you traditionally find. I suppose, what the panel is made of is what delivers the properties. The OSB, the extruded XPS insulation, C24 kiln-dried machine timber, and the structural adhesive. CNC machined as a finished product then gives some of the features that has been looked for and sought by people to improve the quality of building stock across the industry. So structure and durability, good U values, accuracy and quality of fit on site is as important as anything else. And when you take the sum of those things together, you get good air tightness and ultimately at the end of the day, high efficiency building. I'm not going to read each line, but you can achieve any number of a variety of U values from exceptional and passive house level, including for air tightness without achieving membranes, low particular values in terms of psi values and bridging, and warm roof principles, which is probably the single biggest difference between that and traditional timber framing. A U value calculation there you can see, but the most important thing is the sectional view, that the attic space becomes inside the thermal envelope. And this has particular advantages for the likes of MH, mechanical ventilation systems and so forth, in that they operate more efficiently when they're inside the same ambient atmosphere as the typical building. All our accredited details are, our thermal details are accredited by NSAI and are available on request. You can see the roof panels, which is one of the key drivers of our system. We specialize in large format panels. Technically, the largest panel we currently make is in the region of 15 meters by 4 meters at the moment. But in the house market, the vast majority of them are 6 meters and under. You end up with warm roof construction. So room in the roof becomes the standard rather than the exception. You have the warm zone for the type of services you're going to put into it. Fixity for the likes of solar panels and so forth is a given as you're on a solid surface, and it takes all standard roof finishes, so nobody has to learn new tricks. Dormers in particular are always a challenge, and you can see from the bottom picture there a complex cut by CNC machine on a roof panel and prefabricated dormers lifted in, and we put 30 to 40 minutes per dormer typically to finish it on site, and you end up with a highly insulated airtight structure. Like many, we invest in not only good quality materials, but also testing to back it up. And we are guided by the same standards as applies to timber framers and concrete builders throughout the country in terms of structure, racking, thermal, acoustic, fire, and air tightness, all of which go together to deliver a quality building. All of our testing has been done by physical example, including party wall construction, achieving 94 minutes. So you're not giving anything up. But the key driver for all sites, and I don't want to repeat so much of the last presenters because otherwise you'll hear it 3 times over. There's a typical 4-bedroom semi-detached house that we're coming to the end of the scheme of in Galway, 122 square meters. It achieves A2. It has an air tightness of 1 cubic meter per hour square meter, per square meter. It has an air source heat pump with underfloor heating to the ground floor and radiators to the first floor, a 70 decibel party wall. And in common with a lot of MMCs, and the differentiator between us and site-built operations is the completion time, 12 weeks. Estimated cost to heat the house for the year is 120 euros. I always say that's an estimate. Different customers and different clients have different preferences, so that's going to vary a small bit. The vernacular of design is that which people are used to looking at. Typical bungalows, 1.5 stories, 2 stories, semis and terraced. And we have a variety of them around the country for the last 15 years in all sorts of scale, from modest to very large. And we also have the halo projects, not only here in Ireland, like on Dermot Bannon's show lately, where we had a house featured, but also across the UK. But commercially, probably the thing that drives us for MMC and offsite construction, and will apply to others too, is time on site. Time on site is the most expensive thing you have, and you need to ration it, and you need to take best advantage of it. But it also allows you to build when you're not building. In other words, people assume that you can't build in winter. Well, of course you can. It's just that you're building in a factory. So you're not losing time, and your program isn't stopping. It doesn't apply to housing. You can see there, for instance, a very large scale school. It's 3,500 square meters, structurally complete in 10 weeks, handed over in 22, operates at approximately a quarter of the running cost of a conventional building. And these are looked at as exceptional. I think it's our jobs in the MMC industry, both Gareth and Gerard and the engineers we want to take part of it as well, is to make this the norm and not the exception. I think that's what we're trying to do here today. So institution use, includes sports halls and then churches. Complex shapes. The bane sometimes of factory manufacture is doable. We don't actually curve the panels themselves, we facet them, but that's the advantage of having CNC machinery. And there's the finished building of that particular one on the previous slide. It has concrete screed floors to the first floor as well. Planar houses and the halo models being very flat and angular and everything, of course, are a boon to factory modification manufacture, but they're not a limiting factor for us. I think probably the key things to get across to people here this evening that are listening, and hopefully to raise questions on it, is that what we're selling is real world expertise. What we're selling is stuff that's achievable. It's not pie in the sky. I suppose the key thing I would always say about our buildings is, or our system is, it's based on efficiency. Efficiency, a lot of people run to that and think, oh, they must be talking about energy. But it's not. It's efficiency of time. It's efficiency of cost. It's efficiency of effort. If you make the building better and it's easier to build it better, then it is more likely to be better. And so we make the end goal easier to achieve. Pricing, of course, is a factor. And without putting on the typical salesman hat, it is important that people appreciate the difference between price and value. I can throw out numbers here, to give people a guideline. But I mean, the one that was on Dermot Bannon's show lately, Meadow House in Limerick, a very, very high-end building. It's built in 26 weeks to completion. Was achieved for 1,550 euros per square meter. I think that's exceptional value. Now, of course, you can do cheaper and you can, rationalize the design, but that's where the work of engineers and architects comes in. We need them to take what we do, feed it into their pocket, and deliver it out to customers with a better end result. There is no reason for projects these days to take the length of time people are traditionally used to. The days of spending a year and a half building one-off houses, there really isn't a need for it. Those of us in the industry know that if we're spending that much time on something like that, you're not going to make money. It's not going to be sustainable. And we need to sustain the industry to deliver volume. We need to sustain jobs, and we need to create opportunities. And we also need to make the people appreciate that what we're trying to do is build something that effectively eliminates fuel poverty. By making a better house to start with good durability for a long life, and you provide comfort to people at an affordable price, they will find it easier to live in that over a longer period. And if you look at the demographics of this country as they get older, that's going to be very important over the next 25 years. You can see there on the screen an example of a contemporary house. Finishes varies there. You see render, you see timber, you see vertical slate. It's built over a basement. It's built on a hill. All the various skills that are in use today on construction will continue, but we're going to rearrange them, and we're going to reissue them, and we're going to take some of them indoors, and all for the betterment of building construction in general. So to sum up from us, what I say is, we're trying to deliver achievable goals for the owner and the developer, and ultimately the end user, whether that's a one-off house through a builder, or you're building a scheme that sells them on through the estate agents of the world. And by doing that, then you create a win-win solution for everybody. And I think it's important that Ireland, and through its engineers and its architects, start to take this as being the norm and the exception rather than the rule. It'll only be for the good. Thanks for your time. I hope it's of interest. What I would say is there's a long version of this with far more detail available from Engineers Ireland that I have provided to them, and they'd be happy to send it out to you by email as a participant, but it would take longer than the 15 minutes, but you can read it in your own time, and I hope that's of interest to you. Thank you very much.
Thank you very much, Sean. That was a great presentation. So we're just going to pass it on to Gerard Clarke there from FastHouse. Gerard, can you tune in there?
Okay. So thanks, John, and thanks John, Moylan and Gareth also. Very interesting, good presentations. So thanks for giving us the opportunity to present on behalf of FastHouse. Just bring up my presentation here, make sure I'm sharing the share screen. Okay, share presentation. You guys can see that?
Yeah.
Okay. So I'll try, it's standard intro presentation that I've put together here, but I'll try and keep it more precise. I'll skip through, apologies, I'll skip quickly over some of the slides, but I'll try and move to the more relevant ones that the CPD has asked me to cover over. So just very briefly about FastHouse. So basically what we do is high performance, energy efficient buildings. We operate across all sectors. Mostly where we're specializing at the moment is the residential sector. We find ourselves now focusing on purely schemes and mostly social affordable housing schemes. So that's sort of where we're specialized. I suppose Gareth mentioned briefly the difference between volumetric, panelized construction, etc. Well, what FastHouse does, it's all panelized building systems. So we've three different types of system. You have an open panel system, which would be traditional type of timber framing. It's mostly used now in UK and Northern Ireland. Mostly what we're using here in ROI is what we call a hybrid panel system. That is where you have all the insulation done in the factory. You'll have the membranes, the air tightness membranes, etc., all done in the factory. And that's where the market is at the moment. Fully closed panel is where we certainly see the future. FastHouse started off as a fully closed panel provider. but we've found that the marketplace is more at hybrid. So what we mean by fully closed is you can have it fully closed from the inside with your plasterboard on, your electrical conduits, electrics, etc. on the wall, windows in, and you can fully close it from the outside then with various board alternatives where you can render or brick slip then onto the board as well. So that's where the future is certainly going and where we see it at. I suppose I won't get too much into us as a group, but we do have a manufacturing plant in the UK as well as in Derry. So we're part of a larger group with huge financial backing from Lagging Group, Kevin Lagging. I'll just flick through some of these. Really, the photo there on the top left shows our factory with 20,000 square foot factory up in Limavady in Derry. And we've been told by many that it is probably one of the most advanced timber frame factories in the UK and Ireland. It has four production lines at the moment, and we're expanding all the time. Just move on. Frame Tech is our sister company in the UK. Won't get into our processes. Really, what we just say is our lead time from date of actually placing an order with us to delivering unit on site is about 7 to 8 weeks. So I can go through that at a later stage with anyone if they need to. Again, I won't bore you too long on design process. All you really need to know is we design everything in-house with the latest 3D design software. It's integrated with all the latest state-of-the-art CNC machining on the factory floor. We've the export capability to get into Revit and BIM modeling, etc. You need to know there the manufacturing process. As I said, we do have all the most advanced off-site manufacturing. We're one of the most advanced off-site manufacturing plants in the UK and Ireland. Not just me saying that, a lot of key developers that have actually visited many of the off-site manufacturing plants that have done due diligence said ours is it's probably our biggest selling point. So anyone's welcome to come up and do a factory tour at any stage as well. So I suppose the topic of today, you're talking about building tomorrow's homes today, and I've been asked how do we improve efficiencies. So looking at modern methods of construction and FastHouse, how do we reduce energy, time and costs on site? So we've all these variety of benefits, I suppose. As the lads were saying there, we need to address the housing shortage in Ireland. And unfortunately at the moment there's inflating construction costs are making it very unprofitable for developers. Skills shortages is going to be a huge problem going forward, which will there be wage hikes, etc. So skill costs or labour costs are going to go up. Supply chain capacity, that will drive up material costs as well. Bank lending is still an issue. It's too costly and there's not enough lending. Building regs are becoming more stringent, which is up in the cost. COVID-19 restrictions we could mention is up in the cost. So the cost of building is going up and up. So pre-manufacturing, off-site and modern methods construction is offering a very good solution to the housing shortage. So I'll just cover some of the key topics that you asked me to mention. So if we look at the energy first, there's two topics I can cover there, from green and sustainable and waste reduction side, but then energy in the actual performance of the building as well, high performing energy efficient buildings. And then lastly I'll just cover affordability and cost reductions and stuff that we can offer. So sustainability first. Well, timber frame is green. It's a sustainable way of building. Always has been. If we're looking at Ireland now, we are facing significant fines. There's some experts are saying up to 600 million. The construction sector is probably a big culprit. So we're facing these fines for failing to meet our carbon emission reduction targets. So we do need to look at building more sustainably. So we would sell buildings that would have low embodied energy. Trees in their nature, the carbon is captured and stored in trees, so we can say they're carbon neutral. They give off oxygen and absorb and capture the CO2 and store it as carbon. So there's various stats out there. I've just pulled up a few what's mentioned. Every meter cube of timber can save 0.8 tons of carbon dioxide from the atmosphere. A typical 100 square meter 2-story building can save up to 4 tons of carbon emissions. There's various stats out there to just prove. And then you have to look at embodied energy that goes into everything that's done to manufacture and put the product there, the building there, all the materials that go into, and what carbon and energy was used to actually produce that building. So timber in its nature, wood can save versus other materials on the carbon emissions. There's various stats that can say up to 5 times more carbon emissions are produced during using other construction methods. I suppose there's a myth of the world's forests shrinking and timber framers are cutting down all the forests. It is a myth. There's more trees now than there ever was. So we only source from sustainable sources. We're growing trees all at a rate of 1,500 football pitches every day is what they're saying. So there's certainly a hell of a lot more trees now than there was 35 years ago. So it's sustainable and green. Just some of our own credentials then. Obviously ISO 14001 will show our commitment to sustainability. But then all our timber is PEFC, so that demonstrates then that we're only sourcing from sustainable, environmental managed forests. Moving on then, just when we talk about energy, then we have to look at the energy performance of the actual buildings themselves. So for Ireland to meet our carbon emission reduction targets, we're going to have to reduce the energy consumed in our housing stock. So we need to be building better, higher performing buildings, and that's what we're really selling. There's been leaps in the minimum standards in building fabric, and we can see that through Part L. If we look at 2005 Part L, which is the baseline that the standards are based on, we have 70% improvement already on 2005 with NZEB. We've 33% improvement with NZEB on even 2011 Part L. So where is it going next? We're on NZEB at the moment. We can see it even moving to passive house standard in the future. So that's where timber frame has always sold itself on being a fabric first approach. So the simplest way of achieving an A1, an A2 house or a passive house standard is looking at the fabric first. And that's where you're looking at your heat losses through transmission. So you're looking at the U values of your roof, your walls, you're looking at quality windows, etc. And you need to address all the thermal bridging throughout the envelope and minimize thermal bridge. So it's like John was explaining earlier about doing the psi value calcs and having your own accredited construction details and thermal modeling done and stuff like that, rather than using your default Y values in your deep software, etc. So there's things like that. Air tightness design is key, and ventilation strategy with mechanical heat recovery ventilation, etc. So these are all the things we're really trying to drive forward as the way of building better, building smarter and higher performing buildings. So it'd be key to what we're about. Typical air tightness would be less than 2.5 at 50 pascals would be our typical air changes, but really we could achieve a lot more with a bit more effort. So that's just talking about energy. Moving on to just mention a bit about waste as well. So there's millions of tons of construction waste that end up in landfills each year. So off-site construction is certainly going to reduce that. We reduced the waste in the factory and on-site. In the factory, it's because you have you've software and CNC machines that have material optimization in there, so we're actually reducing a lot of waste there. And on-site as well, because you're building in the factory, there's a lot less main materials waste on site, so it's a safer site. But you're also removing the likelihood of damaged materials, theft materials, etc. So you're just reducing waste all around. And then by reducing time on site, we can also look at the carbon emissions of the vehicles and the site traffic and everything. That's not just workers and the amount of workforce going to a site, but it's also just the movement of machinery on site. There's stats out there to say 83% reductions in site traffic from using off-site construction. You have less air and noise pollution, etc. So it's good all around. The on-site activities then are reducing your disruption to the local community as well as the local environment, because you have less heavy machinery and vehicles moving around the site, and less pollution, less movement to the ground, and environmental disturbance, etc. So it's good all around from sustainability. Then, as I think it was John had mentioned, time on site is what it's all about. That's how we're reducing costs. We're really, what we're about is selling speed. We're selling reduction in your overall program costs. So this typical pair of semi-detached houses, we done this with our sister company Lagan Homes. They return a turnkey pair of semis. They were saying 18 weeks, sometimes up to 22 weeks. Where with our closed panel system, we were doing it in 7 weeks. Now hybrid would be about 10 weeks. So we're typically saying you could have about a 10-week saving of time on site, but it's that time on site, you have to look at the overall costs of those 10 weeks. So these are just some of the statistics. We would say 70% faster than traditional build. You see many people throwing that out there. We can be with the closed panel. Typically what we're doing is giving a weather-tight envelope in 2.5 days for a pair of semi-Ds. So we're averaging 4 units per week on site. That would mean you would have your basically day 3, day 4, you could have your windows in. So it is quite a fast, and then you can have your follow-on trades lined up quickly afterwards. So it is quite a reduction in your program. The what else worth mentioning? You're getting more predictability with your costs, your weather conditions and stuff like that. So you've more control over your program, guaranteed delivery date, cost certainty, and then labor costs. As I was mentioning earlier, you're going to have costs of labor going up all the time. So there's just some of the key considerations. So really, for it to be a success, we're finding timber frame versus block. In many analysis that are done by various QS, you're talking that they build block houses cheaper. And they will if you don't. The key is you have to engage early with an offsite manufacturer. It's vital to cost savings. You have to maximize the value engineering opportunities. And what we mean by that is, like, we can design for repetition. You design out different features in design, protruding elements. So we try and design out cost really. We can look at differential settlement issues and material optimization on steel and stuff like that. So if we're engaged early enough, is key. And minimizing house types, that's where it often goes wrong. If we can get a large development with only 4 or 5 house types, you're really into cost savings at that stage. So if you take a traditional block designed project with 10 different house types, yes, it's probably cheaper to build in masonry. But if you engage with and design for manufacturing in mind, that's definitely key. The other problem we're finding is they'll get the timber frame kit delivered very quickly, but they won't have the follow-on trades and all engaged and having a sequence of work. So the timber frame kit is often sitting there 3 weeks before the follow-on trades go in, so they're not reaping the benefits of the speed, and that's really where the cost savings will be made. So reductions in prelims is really what we're selling. So everything from your staff, your overheads on site, your security on site, your off hire of scaffold, off hire machines, stuff like that. You're basically all those prelims. When we're looking at costs as well, you're looking at whole life costs. So construction defects, reducing defects and snagging over the life of the building, because typical timber frame now has proven we've 60-year design life on most timber frames. We design and built IS 440, which has a 50-year service life. So it's the overall cost of the building. You need to look at the energy consumption of the building, the cost in use over the life of the building. And if we're building to exceptional air tightness or FastHouse standard, those costs need to be factored in as well, and that's where the cost reduction. So, lots not covered. Didn't have enough time to go through everything. If anyone wants more information, I have a much longer version of this presentation that goes through accreditation, certification, various testing, fire acoustics, thermal air tightness. We can go on and on. There's quality assurance procedures in the factory. We've stuff on site about field management software, etc. Safety is a key factor with off-site construction. It's safer in a factory and controlled environment, and it's safer on site as well when you're pre-manufacturing. A lot of case studies and project videos I usually go through, and presentations I can pass that on afterwards. And we usually go through different product options. Then we're we're flexible with our scope of works, so we can do everything from supply only. We can offer a variety of different specs. And that's really just. So hopefully I've covered the main topics, and hopefully you've given enough information for you to consider FastHouse on your next project. And thank you for listening and giving your time. Hopefully that's back to you, John.
Thanks very much, Gerard. That was a great presentation. So we're just going to make a start on the questions and answers.